All right, I'm going to show how to do these problems two different ways, okay? The first way I'm going to show you is I just want to show you algebraically. Okay, so things that we have to know. Roots means where's it across the x-axis? Okay? So basically what you do with this, if you had roots, if doing algebraically, set y equal to 0, multiply both sides by x plus 2, so then you wind up with just this. It cancels out. Is that okay so far? So basically what I did from this step is I multiply both sides by x plus 2 and x plus 2. The x plus 2's cancel. This becomes just 0. And then I have this. So I'm going to square both sides. Well, 0 squared is 0. And then you could solve this, and you could add 16 to both sides. So root, and don't forget the plus or minus. So plus or minus 4. So basically our roots are at 4, 0 and at negative 4, 0. So that's the algebraic way to do it. Now, being that you are allowed to use Desmos on anything available, let's say you're doing this problem, you're like, dude, I totally don't know how to do it. Well, let's go to our friend, the Desmos family. Okay, so I'm just going to graph y equals square root. I'm going to find that. Square root of x squared minus 16. And then this whole thing is over. There we go. X plus 2. All right. So you're right there seeing, for the most part, the entire graph. Okay. It's going to keep going forever to the left, forever to the right. So if we wanted to look at the roots, we're looking where it crosses the x-axis. So we click here and we click here. Problem's done. Those are the solutions. What does the x plus 2 in the denominator do to us? Really nothing. The reason why it's not doing anything to us is, first off, because we're doing this square root function that is going to not involve anything between negative 4 and positive 4. If I were to take the denominator and say, where's the denominator equal to 0? The denominator is equal to 0 at 2. Okay, so here makes this undefined right here. So we're not seeing that though, because our graph, even graph with it what's shown, is showing this. Okay, so our roots are negative 4 and positive 4, so that's definitely the way to go through the first problem. The second problem, which I have here, says this is our f prime. Okay, so we already have our derivative. Agree? So this is our derivative graph, or derivative equation. Okay, so I'm going to go ahead and just make ourselves a sign line. If this was set equal to 0, I get 0, right? So 0 is one of our critical values. And the reason that's a critical value is we already have the derivative, so we're setting the derivative equal to 0. If I set this equal to 0, I'm going to get this, add 2 to both sides, bless you, so I get 2. But if I set this to equal to 0, what does the denominator set equal to 0 find us? Finds us negative 3. So I'm doing this one in red for a reason. This is a vertical asymptote. Okay? Now, the reason it's a vertical asymptote is it's an undefined term at negative 3. Okay? So we have to kind of think about what our graph is doing. So we have to realize that negative 3, because it's in the denominator, creates a vertical asymptote. Okay? And that's part of our derivative. This is what our derivative is. Yes, there is a way to do the antiderivative, which is called the integral of a derivative, and you get back to your original equation plus something called a constant. So for right now, I'm going to put a question mark there for a moment. So let's think of this. Let's pick a value way out here at negative 10. Okay? So negative 10, if If I plug negative 10 in here, this would be positive. If I plug negative 10 in here, this would be negative. If I plug negative 10 in here, that'd be negative. So if I went positive times negative, I would get negative. Negative divided by negative is positive. So over on this side, it's positive. So then I'm going to pick, oh, I don't know, let's pick a value like negative 1. Okay, and we'll do this one in purple. Okay, so this is just a test point. It's not a critical value. This is just telling us whether we have a positive or a negative slope or a zero slope. If I take negative 1, plug it in, negative 1 plugged in here, that gives me positive. Negative 1 plugged here is negative. Negative 1 plugged in down here is positive. So positive times negative is negative. Negative divided by a positive is also negative. So I have a negative slope in this region. Okay? Then I'm going to pick another critical value. Let's pick, I don't know, let's pick a nice pink. So let's pick 1, because 1 is somewhere between 0 and 2. So if I plug 1 in, this would be positive, this would be negative, and this would be positive. So positive times negative is negative. Negative divided by positive is also negative. So friends, what can you tell me about 0? Is it a max, min, or a point of inflection? Okay, because the signs stay the same. Okay, point of inflection, very good. Then let's pick, say, a value way over here. Let's pick 10. 10 squared is positive. 10 minus 2 is positive. 10 plus 3 is positive. Positive times positive is positive. Positive divided by positive is also positive. Okay, so what's basically taking place is our graph, what our graph of our original function could look something like. Come on, you piece of you know what. So if I have an xy axis, right now at negative 3, I have a vertical asymptote. So what's basically happening is the graph might look something like this. Look like that there. And then over here, it's coming down like this until it gets to 0. And then it changes direction and becomes still more negative until I get to 2. And then at 2, it's doing this. Okay, so right here, at exactly this point, the slope is equal to 0. So this point right here at 2, this was 0 here, at 2, we would have something, it's called a minimum. We might want to call it the correct term. It's called a local minimum. Okay, but that's for the most part what our graph would probably somewhat look like, something like this. And this might go straight up like that. Okay, so that's what's taking place with what our original graph would look like. Okay, because I know what the slopes are based on the derivative, that's how I know it. Did you get all done? Yeah. Thanks, sir. Anyone else get done with that quiz?
I'm almost done.
Cool. All right. So that one's a little trickier to kind of think about. We're using, because they gave us already the derivative, if you set the derivative equal to 0, that's basically telling you where the slopes are taking place. But the big thing to know there is the vertical asymptote is not, it's not really a critical point. It's just a value that does take place on our graph. All right, problem number 3. We want to see where it's increasing or decreasing. Okay, so I'm going to do it the calculus way, then I'm going to show it on Desmos, and they both should match up. So g prime of x should be equal to 15x to the 4th minus 15x to the 2nd. Did I do my derivative right? I sure hope so. So I'm going to set my derivative equal to 0. And if I do the algebra, it looks like I can factor out a 15x squared from both. And that's going to leave me x squared minus 1. And if I say 15x squared equals 0, divide by 15, take the square root. I'm going to get 0. That's a critical value. If I go x squared minus 1 equals 0, add 1 to both sides. Take the square root. So I'm going to get plus or minus 1. Okay? So our sign line is going to look something like this. I have -1 here. I have 0 here. I have 1 here. Let's pretend I could space out really well. So let's think about what some values are going to take place. Okay? The labeled ones are the critical. This is my F prime chart. But I'm going to pick a value like -10. Okay? If I take -10 and go -10 times itself 4 times, it's negative, 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 which is positive, which this is a really big positive number. This is also a really big positive number, but this one's bigger. Agreed? Okay? So if I were to look at, let me backtrack. I'm sorry. I'm looking at the derivative. If I take -10 and plug it in here, that's a really big negative number. If I plug it in here, that becomes a positive number. So a really big negative number. So over here, we have a negative slope that's going to take place. If I try and pick, say, 1/2, see what happens if I plug half in. If I plug half into my original, half to the 5th power is 1/32. So that becomes 3/32 minus 5 times half, half, half. That's 1/8. So is 3/32 minus 5/8, which is the bigger fraction? Would you rather have 3/32 of a pizza or 5/8 of a pizza? Would you rather have a pizza cut into 32 equal-sized pieces and you had 3 of them, or would you rather have a pizza cut into 8 pieces and you have 5 of them? 5/8 is bigger. So that would make this would make a negative situation take place. So this is negative here. If I pick the 1/2 here, so what do you know about 1, or -1? Max, min, or point of inflection? Point of inflection, because the signs stay the same. If I plug half in to our given, this is going to give me 3/32. Oh, wait, you know what I did? No one stopped me. This should have been -1/2, shouldn't it? Stirrup is dumb. So that's negative, positive. Okay, so it should have stayed negative. Okay. If I plug 1/2 in, I'm going to get 3/32 minus 5/8. And that was positive I'm plugging in. So this would give me result in the negative as well. So what can you tell me about 0? Point of inflection as well. Ooh, this is a kind of a tricky looking thing. All right, and then if I pick, say, 10, 10's way over here, plug 10 into our original, that's a really big number. Okay, that's 10 to the 5th, 10, 100,000, 10,000, 100,000, so that's 300,000. Minus 10 to the 3rd, 10, 100,000, minus 5,000, that's positive. So that would give me a positive number. Okay, what can you tell me about 1? It's a minimum. So I go from a negative to a positive slope like that. Thank you.
Thank you.
And that's going to be a minimum value. So this is a min. So let's say we get stuck on this. We're like, I don't know quite what this graph's going to look like. Well, I'm kind of curious to see what 2 points of inflection looks like, or actually 3 points of inflection, -1, 0, and 1. So let's bust out and go to our Desmos friend, take a look at our graph. And now we get to see if calculus is correct or blatantly wrong. Let's just prove calculus wrong. That'd be awesome. Y equals 3x raised to the 5th minus 5x raised to the 3rd. Ooh. let's see. So -1, we have a max. 0, we have a point of inflection. And at 1, we have a min. What did we do wrong? I plug it in right? It's plugged in right. Let me zoom out, just make sure there's no other goofiness taking place with our graph. Yeah, we should be fine. Huh. All right, let's go back and see where I made a mistake. So I said at -1, we obviously made an error there. Where was my error? Oh, I see it. When I plugged this 10 in, this should have been a positive. So positive to negative would have been our max. Point of inflection I agree with. And then that should have been a min. Yep. Now it's right. I just made an error plugging in a -10 there. When I plugged -10 in, that should have worked better for us. -10 plugged in. Yeah, that works. Silly me, I apologize. So, cool. I think I could go ahead and assign you more of this sheet. So on 218, we didn't do anything yesterday because a lot of people were off. Let's have you do 4 through 7. So on worksheet 5.2, let's have us do 4 through 7, all of those. So I'm kind of going a little slower because this stuff gets a little nitty-gritty goofy. And I'm going to save